Good afternoon. During the last lecture, we have discussed about the background of dimensional analysis along with dimensions, units, and dimensional homogeneity. So today we will discuss about non-dimensionalization of equations. So if you refresh your mind, you will remind that the laws of dimensional homogeneity current is that every additive term in an equation has the same dimensions. It follows that if each term in that equation is divided by a collection of variables and constants whose product has those same dimensions, the equation is reduced to non-dimensional. Simply, we can say that each term in that type of equation is non-dimensional or dimensionless. So let us consider the Bernoulli's equation. Hope you can remember that the dimensions of the terms p over rho g, v squared over 2g, and z over z is equal to the dimensions of length. So if we divide the whole equation by some length, it will become non-dimensional equation. So the Bernoulli's equation can be rewritten as p over rho g c naught plus v squared over 2g c naught plus z over z naught is equal to k over z naught, which is then equal to c. This c is c, and all the other terms have no dimensions, which means they are dimensionless. So let us see how to write this in more generalized form. If a1 plus a2 plus up to an is equal to k, where k has dimensions, we can divide this whole equation by a dash, which is having the same dimensions of all these quantities a1, a2, a3 up to an and k. So once you divide it, the new equation becomes a1 over a dash plus a2 over a dash up to an over a dash is equal to c. This c is dimensionless. So there are several methods to generate non-dimensional parameters. Among them, most popular and the simplest method is method of repeating variables, introduced by Dr. Edgar Buckingham, who lived during 1867 to 1940. So this method is popular as Buckingham Theorem or Phi Theorem. According to this Buckingham Theorem, also called Phi Theorem, if any relationship is in a form of q1, q2, q3 up to qn is equal to 0, it can be reduced to a dimensionless relationship among n minus m number of independent dimensionless variables, where m is the number of fundamental dimensions and n is the number of parameters involved in the problem. So to obtain non-dimensional groups or phi groups through this Buckingham theorem, there are 5 main steps involved. Firstly, we have to list the parameters in the problem and count the total number n. Let us discuss the steps involved in Phi theorem through an example. Let us consider a setup of ball falling in a vacuum. To address this example, first we have to define the datum. If the elevation of the ball with reference to that datum is z, this z at any considered time is a function of time, initial velocity, initial elevation, and gravitational acceleration. So that there are 5 variables, meaning our n is equal to 5. The next step is to list the dimensions of each parameter. In this particular example, we have 5 variables and we have to list the dimensions of each and every variable. So the dimensions of z and z0 is equal to the dimensions of length, that's L. Dimensions of time is equal to simple t, and dimensions of w0 is lt minus 1, and dimensions of gravitational acceleration is lt minus 2. Then after listing down the dimensions of all the variables, we can calculate the number of 5 groups or the number of non-dimensional groups. So for that, first we have to find the number of primary dimensions involved in the parameter. Then subtract that number from the total number of variables. So the result gives you the expected number of 5 groups. In this particular example, only length and time are involved as primary dimensions. So the number of primary dimensions equal to 2. That's j is equal to 2. Taking the difference between number of variables, that's 5, and the number of primary dimensions, that's 2, we will get expected number of 5 groups for this particular example as 3. That's k is equal to 5 minus 2 equals to 3. Step 4 is to choose repeating parameters. This is the most critical and challenging step involved in all 5 steps. Generally, the number of repeating parameters should equal to the number of primary dimensions. Since this is the hardest part of the method of repeating variables, several guidelines have to be considered. So these are the guidelines to be considered for choosing repeating variables. Most importantly, a dependent variable cannot be a repeating variable. You can't select a dependent variable as a repeating variable. Also, they must not form dimensionless groups by themselves. For example, you can't select 2 parameters with same dimensions as repeating variables together. Or in a more clear words, you can't select acceleration, velocity and time together as a repeating variables. Because if you divide the velocity by the product of acceleration and time, it will be dimensionless. So you can't use those 3 parameters together. Also, when you select repeating parameters, you have to make sure it includes all the primary dimensions. If the parameters include mass, time and length, then you have to select repeating parameters which include all those 3 primary dimensions. And make sure never pick 2 parameters that already dimensionless or 2 parameters with same dimensions as repeating variables. Also try to pick commonly using repeating parameters. Generally in fluid mechanics, length, velocity, mass or density are used as repeating parameters. So whenever possible, you have to make sure you will select those parameters as repeating parameters. Also, it is better to select simple parameters with 1 or 2 basic dimensions rather than selecting complex parameters. For example, it's good to select velocity or acceleration as repeating parameter rather than selecting pressure or force. So these are the guidelines to be followed to select repeating parameters. So let us move to the example. In this particular example, you can't choose Z as repeating parameter because it's a dependent variable. And also you can't select Z and Z0 together as repeating parameters because they both have the same dimensions. Further, it is not wise enough to select time as repeating parameter because our concern relates with the non-dimensional height. So by considering all these facts, let us select W naught, that's the velocity, and Z naught, that's the initial height, as repeating parameters. And in the step 5, it's construction of 5 groups, and if necessary rearranging them to have predefined non-dimensional parameters. In this particular example, we have to create 3 5 groups. First 5 group has to form by considering independent variable. Let us consider Z with W naught and Z naught. The notation is like this. Phi 1 is equal to Z times W naught to the power A into Z naught to the power B. So then we have to substitute the respective dimensions of each and every variable. It gives L times Lt minus 1 to the power A into L to the power B. Then we can equate the exponents of each primary dimension to 0. So by considering the exponent of time variable, it gives A is equal to 0. So then by equating the exponent of length to 0, it gives B is equal to minus 1. So now we have created our first 5 group as phi 1 is equal to Z over Z naught. So that's our first 5 group. Similarly, by considering other 2 parameters, meaning time and acceleration with the repeating parameters, we can form other 2 5 groups as phi 2 and phi 3. So phi 2 is equal to W naught T over Z naught, while phi 3 is equal to Z naught G over W naught squared. However, by taking the square root of phi 3, it can be rearranged as W naught over square root of G into Z naught. So now we have completed calculating all 3 5 groups. Phi 1 is equal to Z over Z naught, phi 2 is equal to W naught T over Z naught, and modified phi 3 is equal to W naught over square root of Z naught into G. That particular non-dimensional group is called as fruit number. So hope you are comfortable with calculating non-dimensional groups, and hope you can now calculate 5 groups for any given problem. So let us move to one exercise. So try to work out this problem by your own as homework. Its lift force of an aeroplane wings is a function of speed of air, chord length, density of air, viscosity of air, speed of sound in air, and angle of attack of wind. So you were asked to find 5 groups. So try to work out it as homework, and let us meet next time with the solutions. Thank you.